So today we are doing a medium problem 281 to find safest path in grid. So we got some grid with empty cells which is 0 and then cells with a thief 1. Now safeness factor means that your position is 0, 0, any adjacent cells including thieves. Safeness factor is minimum Manhattan distance from any cell in the path to any thief in the grid. And we want to return maximum safeness factor of all paths leading there. So basically here all paths go through here. I mean, this is min-maxing, which usually sounds like binary search, but we need to decide what even is the safeness. Check some other examples. So here minimum path is basically 1, 1, 1, 2, 2, 2, right? So maybe if we put the distance on each cell and then we basically want to do BFS DFS, what are the values? No, distance is so basically this would be 0, 1, 2, 0, 1, 2, 0, 0, 1, 2, 0, 1, 2, 0, 1, 2. And then what we want to do? Well, we want to find such path that minimum number along that path is the highest. And if we say there is a path with minimum number 2, there is a path with minimum number 1, and so on. So basically, if we find a path which has a minimum value of so we want to try to find the answer with binary search, and at each point we just check if we use only cells that have value at least this, can we get here? If yes, then we check that value or higher. If not, we have to check smaller value. First we have to run like should do like this. This is 0, and if this new I, new j is this new I, this ci cj plus 1, and I and j, fair enough. And then what we do after we have distances to everywhere, so then we do binary search on answer, which can be what at most n plus n, and then we just want to use cells with mid, so again we do so current minimum is this 0 0, while q, I will just straight up copy this because I could not be less bothered. Write the BFS again, was just ridiculous. I will copy this for visit it. While q is ij1. Wait, we want to do this. If this 0 0 is less than the allowed distance, no minimum safeness factor, so if it's less, if it's less than then what? If it's less than m, then we want to use a higher distance, right? No, we want to use a lower distance. There needs to be plus 1 if we are doing it. And then we want to do whatever. Then this ni and j is 1, and we just straight up do this. And then current min current list ci cj, and list ni and j such then equal to mid. If this we go to the last position, then okay, we can search larger values, else we do this, return L, something not closed, so maybe this was also almost works. Interesting. Because v is 0 0. So how did it even work without it, right? something like safeness factor 3 can we do? Safeness factor 1, I don't quite understand why these things are not visited. That's weird. How am I at minus? What? Oh, see, I see. No, don't submit. Horrific. Three, two, one, 4, 3, 2. Two, 1, 0. No, so we do 0, 0, and then why don't we do more? You kidding me? What is that? So can you tell me why wouldn't you allow this with distance 1? I'm overwriting. Are you kidding me? Oh my days. How did I not notice sooner? You have to be screaming through the screen if you are watching this. Already that here is M. Okay. Not printing anything. No. Okay. 5,500. I don't care. I go optimal. Just wanna go to sleep. So. Oh. Okay. So first, shortest distance. Each cell to the closest thief. Then we basically want path from 0, 0 to minus 1, 1. Calls with largest minimum value. We can notice that if there is a path minimum value x, there is a path with x minus 1. Therefore we can use search on the answer. We just check. We just search for the largest x, 0, m plus n, and for each x, check if we can reach n minus 1 from 0, 0, going through cells with x or larger distance to nearest thief. DFS/BFS. If we can get to the bottom right cell, we set the upper bound of binary search to x, this with binary search normalized. So there is log n plus m iterations, and each takes O n plus m to run the reach to check reachability with BFS. We also reachability. We also run a single multi-source from the fifth cells. Also run a single multi-source BFS from the fifth cells. To find the, they write it in here. First we find the fifth. Can do with a simple multi-source BFS. To find the nearest fifth for time complexity n plus m, since we have to store distance to nearest fifth for each cell, and also have a visited to the array for visited grid for the binary search reachability BFS slash